Hi, my name is Joshua, and thank you to the VULNCON team for having me here. It's great to be in Bangalore. Not great to be stuck in the traffic, though. But my name is Joshua. I'll be talking about a simple topic. Actually, I share this topic with a co-researcher. His name is Shaleen. He got into an accident with his leg because he was celebrating RCB's win. So he couldn't be here. I'll cover his bit. So let's play a game, right? You have secured all your human identities. You've made MFA or multi-factor authentication very stringent for all of your users, and still I am able to log in with a token that was leaked in 2020. I have privilege and I am active. Who am I, right? And that's the question we in defense, in security in general keep asking. Who are these new things, new vectors that are coming in, right? And that's what I want to answer with this little bit of a talk where I introduce the concept of non-human identities, because cloud is not just made of basic human identities anymore. But to introduce this, and as defenders, we are always in this cyclic game with adversaries, or the cat and mouse game. I call it the infinite game as well in game theory. But I'm a millennial, right? Game theory is a little above my standard. So I'll introduce it in the way I know it. We'll play a retro game, right? So blow out your cartridges. This is a 32-bit game of making you understand how NHIs work, taking an example of the Azure OAuth application that is registered in Entra. Now, like any game, to start it off, you have to choose your players. Unfortunately, Shaleen is not unlocked today. He is away. So I'll be playing for both as player A and player B personas, right? So my name is Joshua. I am from Pune. I work with Microsoft. I'm an NHI enthusiast, non-human identity security enthusiast. If I'm not here, I'll be on a motorcycle. If I'm not on a motorcycle, I'll be spamming you with memes, right? I think some of the team in VULNCON knows. Hence, I go by the name of Advanced Persistent Memer, right? Okay, so now you got a player. Now I got to introduce the vector or the game we're playing, right? What is a non-human identity? Now, this is a new marketing term for basically machine identities. If you've had the older computer systems, they used to be called machine identities, your service accounts, and all of that. But today, it's evolved a little more. And with agents and your LLM, it's become even more hard to define. But let's try and define it real quick. So non-human identity are machine identities. This can be your applications, your tokens, your tenants, your agents that is talking to you, right? Or even a vendor's software automation that is running against your company, right? And why is it becoming important? Because firstly, of course, it powers automation, easy to integrate, everything is integrated, and it's cloud native. So we are going to focus mainly on everything cloud, right? And often, they have more privileges than a user. This is one thing that always will happen because your automation accounts have more access to databases, servers, and resources. And more importantly, today, or as of 2024, based on data available, your user identity to your non-human identity in a typical enterprise, the ratio is 1:17 in a typical environment. And this number grows. Now, with this number growing, think about it. When you get breached, this number can be more. And hence, we have the apocalypse of applications which just flood into your breach. To get through this, okay, let me introduce you to my three friends here. The blue-colored ghosty is the compromised app or the compromised ghosty. These are legitimate application or identities that got breached. The orange or the red one, based on your perspective, is the malicious ghosty or the malicious application. These are designed to get and do bad things. And the last one, the white color one, is your dormant ghosty, someone very important who I'll introduce throughout this whole talk as we delve into actual attacks which happen on the cloud. Now, dormant ghosty is white specifically because it can be any color also. It can be compromised, it can be malicious, it's just there, and it can be used in many ways. So these three ghosties are what APTs use very effectively. Well, take a case in point. We'll take a case of understanding the battlefield. So like any game, you need a field, right? If you think of cricket, you need a field to play. You take a football, you need, the field to play on. If you want to play chess, you have to play a chessboard. For defenders and security, we have the MITRE matrix. This is specifically just the SaaS matrix. The enterprise matrix is much bigger because it has servers and all that. Now, if you see very easily, on the left or my right is your adversaries, right? And their job is to move from this field to actually impact their job, hence this field. And on the left, or your right, is the defenders. And our job is to make sure we can move from left to right as much as we can. And this is where the game happens. This is the field we've set. So to make it more transparent to understand this, let's take the example of a real case. APTA. I'm not giving any names to the APT unless it's China. So they get into the system pretty easily, and they'll use these two personas that I've introduced. So what they initially did was they actually get valid accounts from as far back as 2020, right? So they got a token from a GitHub repository somewhere, and they logged in. So today adversaries don't hack. They just log in. It's very simple. And 2020, something very important happened. COVID came in, right? Everyone was working from home. So SaaS became prevalent. People thought passwords need to be secure. Tokens replaced it. Tokens are passwords only. So people forget. So this is how they got in. But this happened in 2023. 3 years later, tokens are active. What did they log into? An application which is dormant, right? But they log in and they reset the secret again because they now want to keep logging in, right? They refresh. It looks legitimate as well. So now they are in your system. Suppose that what they do is, using that, they start going through your cloud. And I'm talking about Azure right now. They'll go to your key vaults. They'll try and understand who has access to what and all of that. Through that, what this adversary understood was, there in the key vault, usually you also share secrets with other identities. It can be your users who can access databases, servers, repositories. They found an application which has been existing on this system in production since 2015, and the token is alive. They take that, steal the token, and now they have proper persistence in your system, where they actually have a valid account with privileges in your production. With that, what they do is quickly they defensively evade. How? Because usually identities access certain resources. So if this was accessing, let's say in this case, Graph API of Microsoft or certain databases, it switched its context. After almost 180 days, this production application is accessing something else altogether different. Completely alternative authentication. And cloud allows that with your NHIs. And that's where context switch happened, and they were able to discover a lot more into the things, because this is where they target, usually, most importantly, your other workloads in the cloud. And this can also be your other clouds. We have hybrid cloud environments also. And that's when they quickly went and usually go after something else. But let's take the example of this one. This is also APTB. This is another adversary. I won't take the name. Russia. Yeah, I didn't say anything. I'm just having a bad throat. So APTB is very well known to do malicious attacks as well. With NHI, you have to also understand how they're designed. Okay? In the case of OAuth applications in Azure, the same application can be registered in multiple tenants. That means you register one, and another company can register one, and it's the same. So everyone has a version of Teams in every company, right? But locally, it is different. It's like your Swiggy application is available on your Play Store, right? That's one app. But on each phone, it is installed. Hence, it is available on multiple phones. OAuth apps work the same way. They knew this. So what they did is they go after test tenants. A lot of companies in cloud, and many companies who work on cloud workloads have test tenants, right? Because you can't test in production. Don't be that person. Okay? So they logged in because test tenants don't have MFA. NHIs usually don't have MFA also, through a single password spray. But because of that, that application was dormant for many years. Because of that, they were able to access it. But now they're still in test tenant. But the way the logic of the NHI was designed, they were able to jump into, you guessed it, the production tenant, right? And they were able to hence get higher privileges. In the production tenant, it had higher privileges. So now it's being able to jump into two systems, from the test tenant to the whole other thing. And it created persistence. So it went after looking at any other applications, usually the same behavior, right? They looked at, oh, is there key vault? Is there many more other identities I can touch? The funny thing is, it also created in the test tenant 20 plus other applications, which it was going to use for the attack. So what it did was, this is the first time a non-human identity also created a user in the production tenant, and from the test tenant consented 23 other applications into the tenant, hence flooding your entire system, right? Now you're seeing the numbers, right? One user, but almost 20 plus applications or NHIs being used in this attack. Why? It's very interesting because this is where defense evasion comes in. Each one of those have a certain threshold. If you call an API too much, your network will catch it. Your anomaly detectors will catch it. These guys have understood that if I have so many, I can just be within the boundary. This is like creating multiple Google accounts to get the free trial. But this is happening in the cloud, just to stay under the thresholds. This also indicates one more thing. They were able to discover very effectively identities in your cloud, which you are also not aware, because hygiene was lacking. People don't understand how NHIs work, right? Because they're very different from human identities. And I'll come to that. But what they were able to do is they were able to discover, they were also able to add certain identities into permissions. So this person was adding, removing, just to see what more they can access. And you can see the numbers happening. Suppose that credential access, because they wanted all the passwords, that's how they retain persistence, they can go further, or they even add this. Sometimes they even add MFA. Adversaries use MFA more than us nowadays. So just to stay under the radar, right? And then they, of course, started collecting as much resources. This is repositories, your emails, and everything, and went away. Now, one of the most important things happened is we are able to understand compromise and malicious as a concept. But dormancy, specifically when it comes to identities, is a very different concept altogether. Because when it comes to NHI or non-human identities, we can't take them as users. User is dormant, meaning unused, meaning you've not signed in, and hence you're not able to use something. But when it comes to NHI dormancy, in this case for OAuth, we had to look at it from a multi-pronged approach because they don't log in all the time, right? So for us, we had to look at API activity. How much API does it use? Does it use anything different? What are the token behaviors? Is the token long living? Hence it's dormant, it's never signing back in, but the token is alive somewhere. Is it signing into something also? Because non-human identities, unfortunately, also have the same amount of power as a user, if not more. So they can create users, they can also sign into other applications. And if someone is signing in. And this is how we were able to create it. This can change from each NHIs, right? This is one example I've taken from one cloud flavor. And this is where I'm making you think. You need to start thinking separately for users. Now knowing that, this is where defense comes in. So for APTA, again, this is where we understood now, if you see where it's gray, we were able to understand color codingly that, oh, which is compromised, which is dormant, and then hence start detecting backwards with each behavior, because now we have context. Because until I have context, I can't write a detection, right? And this is where we started being able to cover each step of the kill chain. Applies to the same thing, right? We were able to understand, okay, these are malicious, some we could, and then we were able to quickly filter backwards towards actually covering till this part of the kill chain. That means we're now being able to see every step of the adversary as they're playing the field with us. But this is where I have this question. We're playing a game, right? If I can play football with you, if you can score a goal, wouldn't it be fun I can score a goal as well? But in security, it doesn't work like that. I think there was some time people were like, can we hack hackers back? It doesn't work like that, though we want to. But there are things that can come in a game. And truly, if you want to think about equaling this playing field, we need to, as defenders, have actions. Deception technology is definitely one of them, but it's still like not the best step because you need to equal the playing field, equal actions. So you have detections. Can we take action? And I'm not saying remediation, I'm not saying IR, post-breach. I'm saying as the detection is happening, can we now do steps? You can. That's where we introduce the concept of disruption. Detection and disruption are hand in hand. As the activity is happening and we know there is a surety of this attack, let the system only take the action. And this is where the thought process of disruption comes in. This is where we equal the playing field, right? So before I introduce even disruption, and this is where actually Shailene comes in as player 2, because this is where we update ourselves from 32-bit graphic game to now thinking actually 3D. And this is where he normally asks, how many of you play first-person shooter games? Any show of hands? Okay. So in first-person shooter games also, you update, right? The better the graphics, the more sensitivity. So what if your systems can be made like that? We already have detections, right? You have amazing detection engineers, machine learning, LLMs have come in. Now how do we equal this, right? And this is where we have to start thinking, how does disruption firstly work different in an NHI? So for my case, OAuth application, let's take the example again. We have an OAuth application which has usually a global identity or a global ID, right? Much like, again, I give the example of any application you install on your phone. In the Play Store, it's known as something. When you install it into your tenants, or your instances of cloud, which you have paid for, it creates a service principal. That's your identity, your number for it. And similarly, it happens for many others. But each one of them has an owner. So the application has an owner, the company who's created it, who's hosting it, and in your tenant also someone who's installed it. Question happens is, it gets installed into so many tenants also, right? And then you have service principals. So your tenant has one, your tenant has one. And each one behaves differently. Who do we disrupt? This is actually me trying to think, who do we disrupt, right? This is actually how defenders look like when you're trying to take action, right? I have a few people from my company, they know this is how we look like in calls. Hence, we switch off our cameras. And this is where we have to actually look at it in the same way of game theory, right? A phased approach to disruption. You can't just delete something. You can't just remove something. Your business is also important. And that's where the concept of game theory becomes very important. The grueling game that we play as defenders in security, right? It's very important first to define who is your king. What is the king for your scenario, right? It's very important. Because in game theory, if you take the concept of chess, the king is the main person you need to defend, right? Other than just win the game. So, who is the king for you? Is it your business? Is it your reputation? Is it uptime? Is it productivity? And that's where you start thinking backwards. That can I now, that I have this detection, where do I disrupt these? And that's where the concept we further introduce, because game theory is a very interesting and a comprehensive framework for this. You can apply it in a phased approach, meaning I just don't remove something. When your computer has a virus, do you throw it in the garbage? There's steps, right? Specifically, if it's running a production something, you look at registries, you look at ways to end the process, quarantining, refreshing, even creating virtual stuff, right? We've gone so advanced in endpoints. Cloud is even more sophisticated if applied properly and thought in the same manner. The principles have not changed. The field has changed. And that's where it becomes very important to start thinking the game in the way of playing the infinite game. Because these guys are not going away. We are getting new stuff coming in, right? So throughout the attack tactics, we look at the user and the business operations as the key to everything. And that's why, again, we go back to this kill chain, right? And we're like, okay, I can detect everything here. Where can I disrupt? So again, we go from left to right. But usually I'm going to take this example from a user identity perspective. When you think of user, we can disrupt it in these segments of attacks. Basically, users we can easily disrupt in these areas. We can just sign them out, give them a MFA challenge again so that they have to refill it or just clean the session or just kick them out, right? But with NHI, it becomes very interesting. And that's why I wanted to introduce you the weapons we used when it comes to these kind of attacks in this NHI case. Being, you can remove the secret, you can delete the service principal which is in your tenant, you can delete the application completely if it's known to be bad, right? The globe does not need it. And then you can remove the service principal credentials. It exists, but you've just made sure it doesn't have access or passwords associated with it, right? Then you can disable sign-ins from the service principal, because remember, they can sign into something, so don't allow them to sign in. You can remove permissions, right? Why can't it access everything? Remove permissions, right? You make it very basic. Least privilege of access is something we do apply. You can apply it here. You can revoke access tokens. So applications have tokens which they can use to access something which is associated with it. You can revoke that. You can disable sign-ins to the service principal, and then you can revoke assignments to it, and also unnecessary high permissions, because we end up liking giving permissions to everything. Ask your DevOps guys, they'll give permissions for everything, right? Now, using these tools and our understanding of basic game theory, now that we can detect, can we actually start disrupting them? So you're not just seeing something, you're actually taking action. That's why it's important, right? So here, this action type, right? Automated collection, right? Let me just quickly reference my notes because this was done by Shaleen. So that's revoking API permission. Now, min-max theory usually says is minimize their maximum profit, right? So they, even if they've gotten access to all data, can we, remove the API permission so they can't go? You have Stackelberg strategy, which is basically if someone has taken a step, you can take a step. So here you can take a step. And in this case, what I want to do is I want to disable the sign-ins to the service principal. right? So at the lateral movement, if they're able to sign into something else, can I disable it completely before you can sign into anything else? Hence reducing the attack surface as well. Next one being the Bayesian inference, because there are evidences around it, right? So here we can quickly go ahead and do revoking of assignments to the application. If it has accesses to certain groups, revoke it. Similarly, it goes backwards, right? You have zero-sum game. So if we can equalize the thing, right? They have more advantage. Can we equalize the playing field? And right here, if you see equalizing, we're right in the middle of the field again. And that's how well the MITRE index has been designed. Here you can take actions like revoke access tokens, and more importantly, the hammer being revoke unnecessary high permissions. And as you see, as we're going backwards, right, we can continuously disable sign-ins, right? Because if you get locked out from your account, you also can log in. But what if it's continuously happening, right? So this is where we bring in repeated game to disable sign-ins for a certain amount of time. Then we have remove secret and remove service principal credentials using Nash equilibrium and the dynamic game of using deletion of your service principals in your tenant. But most importantly, the containment game. Because if they can't get in, how can they do all of this? And that's where the understanding of thought process, where detection, when we have created a context, what if we can take the steps right there? Take the same example with APTB. All the steps till persistence almost is the same, right? Except for the last bit, because this is where so many applications were logged in. And this is where you can apply your own strategy. In this case, we can disable all these applications. Why are so many malicious applications which you don't know about getting consented in, right? This is where you can also delete some of the credentials that are associated or of the user who's signing them in. And more importantly, play actually the dynamic game of deleting the entire application, because as a customer or any provider, your provider would love to hear from you. And if they know it's bad, they would disable it not just for you, but for the other customers as well. And that's where containment comes in very importantly, right? Because your action then, or anyone's reporting action, helps to contain it. Now there is where the thought process further evolves. This is where we level up. Because usually when a customer reports to us or reports to any provider or any service provider, right, they start looking at it, how is it affecting globally? And that's where cybersecurity has always been. It's a team effort, right? It's not a single, it's a team sport. And that's where we have to start thinking of strategic disruptions in a phased approach with each detection, but also reporting it to your providers, because inactivity maybe in your tenant also applies globally. And this is where clustering behaviors across tenants becomes very important and very easy to understand. And hence, with that, we actually end up asking our adversaries, the game is actually on. Thank you.